Hi Theory students. In part 3 of our chapter on modes, scales, and sets, we'll be talking about non-diatonic scales and the basics of set notation. Besides the diatonic scales, which include our major and minor scales and the various modes we talked about in the last part, there are other scales that have commonly been used in modern music. The most frequent are pentatonic, whole tone, and octatonic scales. Pentatonic scales show up worldwide in a variety of cultures and styles. I'll show you two different versions of pentatonic scales. Imagine that there are two different orders of the same 5 pitches. G, A, B, D, E, and then back down. Now imagine if I'm starting this same 5 pitches, but now starting on E. The first scale is like a major scale without scale degrees 4 and 7. The second scale is like a minor scale without scale degrees 2 and 6. Let me show you this on a staff. So imagine that the first scale, G, A, B, D, E, is like a G major scale without the C and without the F sharp. And that the one on the bottom is like an E minor scale, also without the F sharp and the C. But of course, in one case, looking at G major, those are scale degrees 4 and 7. And in E minor, these are scale degrees 2 and 6. These are not the only possible pentatonic scales, but these are often used. Neither of them has any half steps, so the technical term for this kind of pentatonic scale is anhemitonic, meaning no semitones or no half steps. So some observations and definitions. The so-called major pentatonic scale, G, A, B, D, E, is a subset of the G major scales, since all the notes are taken from the larger pitch set, the pitch set of G major. If we consider a black key version of this, G flat, A flat, B flat, D flat, and E flat, it forms a complement of the C major scale, meaning all the notes of one set added to the notes of the other set give us all 12 chromatic pitches. I'll show you this. So here on top and on the bottom, note I'm going to sort of draw arrows showing the notes that we don't have. Which demonstrates that I've now got all 12 pitches if I combine these two together. This is called a literal complement, but it would also be true that any other pentatonic scale built like this is a complement with any diatonic scale. We just need to find the right transposition in order for it to be a literal complement. The collection of all 12 pitches is called the aggregate, and however we split up the aggregate, the two sets that make up that split would each be complements of the other. In addition, the minor pentatonic scale is symmetrical if we write those notes here, and take the interval minor third, major second, minor third, it works the same forwards or backwards. Composers in the 20th century liked to use symmetry, and this shows up in many ways in many different pieces. The whole tone scale is, as the name implies, built from all whole steps. There are only two different whole tone collections. This one and the one a half step higher. Note, by the way, that this one, I'm considering it the same pitch collection whether I start on E and go up whole steps, or whether I start on C and go up whole steps. We call those two rotations of each other. And that one of the reasons why these whole tone scales sound so free-floating and without pitch center is because they don't have any perfect fourths or perfect fifths in the scale. Also, the two collections, this one and that one, are complements of each other. Add all of those together and you get all 12 chromatic pitches. As just mentioned, whole tone passages have a distinctive sound but can seldom be used for very long. Without perfect fourths or fifths, and with only the augmented triad as the only triad possible, the music seems to float without a strong pitch center. Listen to the example in the book from Debussy's prelude entitled Voile. Most of that piece is in whole tones, but it's not a very long piece, and there aren't many pieces of music of any length that are entirely in whole tones. The third scale I'll show you today, the octatonic scale, octatonic meaning 8-note scale, the same way pentatonic means 5-note scale, is built from an alternation of half steps and whole steps, and you can start the scale with either a half step or a whole step. If we just consider the pitch collection and not the different scales you would get, let's say starting on a C versus starting on a D sharp versus starting on an E, then there are only 3 distinct octatonic pitch collections. Note here we have a half step, and then a whole step, a half step, and then a whole step, a half step, and then a whole step, a half step, and then another whole step. This was the scale I just showed you. If I start from the C sharp, only this time instead of going up a whole step to D sharp, if I go up a half step, I get this scale. Half step, whole step, half, whole, half, whole, half, and whole to get back to the C sharp. Now if I start on the D, I'll get the third different octatonic pitch collection. Note that the complement of any octatonic scale is a diminished 7th chord. We could also say that the octatonic scale itself is built by combining any two different diminished seventh chords. For that reason, this scale is called a diminished scale by jazz musicians. Let me demonstrate this to you for the scale we just looked at. So here, if I write the notes that are not in the octatonic scale on top, I've got D, I've got F, that's the one missing here, I've got A flat or G sharp, that's the one missing here, and I've got B or C flat, depending how you'd like to spell it, that's the one missing here. In addition, C, D sharp, F sharp, A is a diminished seventh chord, C sharp, E, G, and B flat is also a diminished seventh chord. So as I said, take any two diminished seventh chords that don't have the same pitches in them, combine them together, and you get an octatonic scale. And the diminished seventh chord that you leave out is just as defining for this scale as the two that you're including. They're complements of each other. At this point, it would be easier to introduce the system of referring to pitches by numbers. Think of the 12 chromatic pitches as though they were places around the clock face, with C being 0 instead of 12, and 10 and 11 represented by T and E respectively. This allows us to include all enharmonic spellings as the same number. For example, 5 would be F or E sharp or G double flat, for example. Your book has a schematic of this, and I took a photo. So here we are, and note the way around the clock. So the scale that I just showed you, C, C sharp, D sharp, E, F sharp, G, A, B flat, and C would be an octatonic scale, and I demonstrated half step, whole step, half step, whole step, half, whole, half, and then whole to get us back where we started. What we can also see, if the ones that I've marked up are the octatonic scale, look at the ones that are left out. D, F, A flat or G sharp, and B. These are each a minor third from each other, and that's a diminished seventh chord. So if we're describing these pitch class sets, let's define those as any group of unordered pitches, meaning they can be used in any order, not one specific order. So if I'm describing that diminished seventh chord, I can use those four pitches in any octave and any order. We'll describe that as a pitch class set, and we'll use curly brackets and write the numbers from lowest to highest for consistency. So for example, a G minor seventh chord, the notes G, B flat, D, and F. G is 7, B flat is T, remember T is 10, D is 2, F is 5. And now for consistency's sake, let me take these numbers and write them in size order, lowest number to highest. The whole tone scale on C, 0, 2, 4, 6, 8, T, corresponding to C, D, E, F sharp, G sharp, A sharp, or B flat. So get more familiar with translating these numbers, these note names into numbers. There are some exercises in the book that will help you do this. We could also label these whole tone scales. We could call this one whole tone 0, the one that includes pitch 0, C, and call this one whole tone 1, the one that includes the pitch number 1, C sharp. Likewise, we could label the 3 octatonic scales. We could call this octatonic 0, 1, because those are the first 2 pitches here. Octatonic 1, 2 from these pitches, and octatonic 2, 3 from these pitches. Become familiar with this kind of labeling notation that we're describing, because we'll be using it as we look at more music. That's all for today.